So today I will explain how to find the sum of given terms of an arithmetic sequence which becomes an arithmetic series. You may have seen many ways of calculating the formula for sum to n terms of an arithmetic series. I'll try to explain it a very simple way. For that, let us consider these 100 numbers or some of these 100 numbers, which are the first 100 natural numbers, right? Okay, so we'll write these numbers like this, and because we are adding, so I have put plus sign between the successive numbers. So let's do this. Add the first and the last number, add the second and the second last number, add the third and the third last number. What you observe? What you observe is that the sum of the first and the last, and the sum of the second and the second last, and the sum of the third and the third last is the same, which is 101. And how many such pairs will be there? I think if you can see clearly, there will be how many pairs? 50 pairs. So 50 times 101 gives me 5050, right? So this is how we can very quickly calculate the sum of the first 100 natural numbers. And now these first 100 natural numbers form an arithmetic series. So I'll try to see the formula or derive the formula from here. Now what I see is that this 50 is the half of 100, which is the total numbers I have here, and this 101 is nothing but sum of 1 and 100. Now I'll try to generalize this formula. Suppose I take n numbers of an arithmetic series, then this 100 by 2 is nothing but n by 2, and this 1 is nothing but u1, and this 100 is nothing but the last term. So this is one of the formulas of finding sum to n terms of an arithmetic series. Now you also know that un, the general term of an arithmetic sequence, is given by u1 plus n minus 1 into d. So if in above formula, if I replace Sn by I replace un by u1 plus n minus 1 into d, what will I get? Let's see. I'll get the other formula that involves the first term and n. So the formula that I get is n by 2 into 2u1 plus n minus 1 into. So as far as IB is concerned, we have these two formulas in our syllabus, and I'll try to explain two questions also that can give you some insight of what kind of questions are asked in IB program or final IB exams, right? So my first question will be related to an inequality. Like he can ask you, like for a given arithmetic series, let us say 100 plus 97 plus 94 plus 91, like this. This is an arithmetic series, and he will ask you, because the series is decreasing, right? Because d is negative, so he can ask you, find the least number of terms that will give a negative sum. Because we know that the terms of the series are decreasing, so a time will come when my whole sum will start becoming negative, and from then on the sum will always be negative. So he wants to know the first term from where my sum will become negative, right? So how to do this? I know that in this question or the arithmetic series, my first term is 100 and my d is minus 3. So I'll try to calculate Sn first, so that I should know, okay, let's assume that there are first n number of terms that will give me my sum as negative. So if I use the above formula, I'll get 2 into 100 plus n minus 1 into minus 3. And if I simplify this, what I get is n by 2 into 200 minus 3n. right? Now we want this sum to be negative. So I'll say n by 2 into 203 minus 3n is negative, right? Now you know that n can never be negative because it denotes a positive number. So I'll say as n is positive, so other expression which can be negative is this. Why? Because I have the product of, you can understand this from here, that if a times b is, let us say, negative, then what are the situations under which we can have this product as negative? A is positive, b is negative, or a is negative and b is positive, right? So because n is positive, so the other term which can be negative is 203 minus 3n, so that my whole product is negative. And if I try to solve this, I'll get 3n greater than 203 and n is greater than 203 by 3, which is 67 is to 2 by 3. So what shall I write after this? How shall I conclude? So I'll say, so least number of terms giving a negative sum is 68. What does that mean? Let me explain it once again. That means if I take first 68 terms, then my sum will be negative. That means if I take 67 terms, 66 terms, 65 terms, and all the terms which are less than 68, my sum will be positive. But from 68 term, like if I take 68 terms, 69 terms, 70 terms, then my sum will always be positive. Okay, I hope you have understood this question. And one more question I want to explain is related to two arithmetic sequences, right? So suppose we are given two arithmetic sequences, right? Suppose we are given that the ratio of, this is a question, that ratio of sum of n terms of two arithmetic series is let us say 4n plus 2 is to 3n minus 9, and he can ask you find the ratio of fifth term. Ratio of fifth term. I'm trying to explain to you the idea of actually the formula for sum to n terms of an arithmetic series, right? Now my first series, I can say let my first term be a and my common difference is d. For second series, I can say, let us say my first term is small a and my common difference is d. Then he is saying the ratio of sum of n terms of two arithmetic series is this. So what will I write? I'll write that n by 2 into 2a plus n minus 1 into d. This is the sum to n terms of the first arithmetic series, and similarly for the second series, the value or the expression for sum to n terms will be given by this expression, and then this expression is equal to which ratio? 4n plus 2 divided by 3n minus 9, right? Let's try to simplify this a little bit, and 2a plus n minus 1 into d upon 2a plus n minus 1 into d. So this value is equal to 4n plus 2 upon 3. Now what we have to find? Please keep this thing in mind, that what we are calculating. We are actually calculating the ratios of the fifth term, right? So basically we are calculating a plus 4d and a plus 4d. This, we are looking for this expression, and we have to extract this expression from this expression. So how can I go first? What will I do is, I'll say, okay, let us say divide left hand side by 2, right? We'll divide the whole left hand side by 2 in the numerator and denominator, right, to balance, keep the balance. And if I do that, what will I get is this d and then a plus 1 upon 2 into d equal to 4n plus 2 upon 3n minus 9. Now what you see, I'm looking for this expression, can you see that we are about to arrive the a plus 4d divided by small a plus 4d if I replace, if, what is the condition, if n minus 1 upon 2 becomes 4, that means n becomes how much? 9. So let us replace n by 9, replace n by 9 in the above expression. What we get is a plus 4d divided by a plus 4d equal to 4 into 9 plus 2 and 3 into 9 minus 2. So what you get is 38 divided by 20. Oh, it's not 2, it's 9 here and 9 here as well. So it is 9, 3 and minus 9. So what we get is 27 minus 9 is 18. So the ratio is 19 upon 9. So what will you write? You will say that the ratio of our ninth term is 19:9.